Hey, today we're going to talk about 6.11, hydrogen fuel cell. So to check out the Enduring Understanding, look at the learning objectives, pause the video, review the essential knowledge, and set up your Cornell notes. So a hydrogen fuel cell is a technology that uses hydrogen to generate electricity, and it operates like a battery. So a lot of this is going to be some review from your oxidation and reduction lessons in chemistry. I'm going to give you the basics, and you do have to understand the chemistry, but you don't necessarily have to understand all of the details. I am showing this to you using like little circles to represent molecules, very much like you're looking at a chemistry model set or molecular set. So it functions like a battery, and one of the things that whenever I think of battery, I think of battery acid. So we can use this little acronym, ACID. At the anode, current is departing. So the current is in the form of electrons. Anytime you have electrons moving, that is electricity. So these electrons are moving through a wire, and that is where we get our electricity from a hydrogen fuel cell. Another thing you can say is Leo, Gur. Leo, a lion, would say Gur, like they're roaring. And loss of electrons or losing electrons is oxidation. So this anode is losing electrons, and gaining electrons is reduction. The cathode is gaining the electrons. So you can use these different acronyms. It will help you out. You will be responsible for understanding where is the oxidation occurring and where is the reduction occurring. Another thing, anode and oxidation both start with vowels. Cathode and reduction both start with consonants. That might be another way to remember it as well. So at the anode, this is where the oxidation is occurring. I'm going to use these little symbols. This represents hydrogen. This represents the H pluses. This are the hydrogen ions without the electrons. And these are the electrons from the hydrogens. Now, this equation is not going to be balanced for the overall reaction because I have different amounts in the final reaction. However, I'm just going to show you, for simplicity, I'm going to show you a simplest form. So at the start, you add hydrogen. The hydrogen goes into the anode where it loses the electrons. And the electrons separate from the protons, and the electrons will travel through this wire. And as they're traveling through the wire, of course, they're generating electricity. Now the electrons are going to the cathode where we have reduction occurring. And at the reduction, we take in oxygen. This is oxygen from the air, so we don't actually have to do anything to pump in the oxygen. But what's going to happen is it's going to lose its electrons and then become it's going to gain 2 electrons and become an oxygen ion or an oxide ion. So we add in the diatomic oxygen. This is how it exists in the atmosphere. And it picks up those electrons and becomes a oxide ion with the -2 charge. And now that oxide ion and those 2 protons or those 2 H pluses are going to be attracted to each other. And guess what? When you have 2 H's and an O, you get water. And the water will leave as exhaust. So water is a waste product from this fuel cell. In fact, water is the only waste product from a fuel cell. Now, this is simplified. This is the balance equation. This is simplified. I don't have 2 waters here. I don't have 2 H2s. I just have 1 H2. So understand that this is a little bit odd, and we would also have more of these O2 minus. However, again, what happens is your hydrogen is coming in, your oxygen is coming in, the electrons are being transferred through the wire where they're picked up by the oxide, and you form water. Now, what is the most important part of this? You are producing energy, you are producing water as a waste product, and you need hydrogen as a fuel. Now, there's 2 ways we can get the hydrogen, and they're both not really cost effective yet. One of them is called steam reforming, and I don't really think you have to know these, or you don't have to specify these different methods. However, you should be familiar that they do release carbon dioxide either directly or indirectly. This steam reforming, you're basically burning methane and you're adding heat to it, and you're getting carbon monoxide, but most importantly, you're getting a lot of hydrogen. So this is producing a lot more hydrogen on the molecular level, but it requires fossil fuels of natural gas. Now, another thing, electrolysis doesn't actually produce carbon dioxide. However, we need electricity, and where does most of our electricity come from? It comes from coal-fired power plants in the United States. So if we're not getting electricity from a sustainable source, then a hydrogen fuel cell getting the hydrogen from a coal-fired power plant is not going to make it a sustainable alternative. So that is a little bit of a drawback to this. Now, here's some benefits and drawbacks overall. For starters, a hydrogen fuel cell is about 80% efficient. So a regular internal combustion engine powered by gasoline is, between 30-35% efficient. A coal-fired power plant is only 30% efficient, and an electric motor is 60% efficient. However, when you're talking a 60% electric motor and then your coal-fired power plant is only 30% effective, like your overall percent of efficiency is going to be lower because you're losing a lot of energy when you convert the fossil fuel into electricity. But that's for another day. For another benefit is there are no emissions during the operation. The only emission is water, and that's a good thing. It's difficult to obtain the hydrogen, especially when we get it from methane. The distribution network, we don't really have places where you can go to a gas station and pump up hydrogen into your car. They're now having charging stations. If you've noticed, like I've seen charging stations around the city, and in other cities they have areas where there's charging for electric cars, but we just don't have that infrastructure yet for hydrogen fuel cells. And unfortunately, because we do have electrical components, there is a danger of fire and explosions. So, for your FRQ practice, I would like you to explain how hydrogen gas can be used to generate electricity. So I thank you so much for your attention. This was probably something new that you've never learned about before. If you have questions, we can talk about the chemistry. Thank you so much. I will see you soon.